Okay, early morning hustle. See, it's still dark. And you know what? You can do it. So today what we're going to do is talk about categorical data analysis, more specifically chi-square goodness of fit. The next video should be or will be categorical data analysis, chi-square test of independence. And they're similar, but they're a tad bit different. All right, so you know the usual. Go ahead and read the description, summary statistics, visualization, and analysis, and then we'll go back to it. All right. All right. So the Washington State Lottery is analyzing scratch ticket color preferences among customers. At a major convenience store, just one store in Seattle, they tracked 400 scratch ticket customer purchases among 5 different color tickets. What they're trying to say is that they, based off of the customer, they find out what their favorite color ticket would be ideally. Okay. The Lottery Commission expected equal preference for all colors, but observed different purchase patterns. All right. So here's that we expect to see 20% each because there's 5 different colors, 1 divided by 5. Since it's equal, we should see 20% of each color, okay? And so with that being the case, do we see that? And so we know that from sample to sample, it's not going to be exactly 80, 80, 80, 80 for all 5 different colors. We should see some variability, but how much variability is too much for us to say that we actually saw what we expected. Okay, so that's really important for us to actually test out. And so that's the chi-square goodness of fit test. And notice that it's just one variable. Okay, it's just one variable, which is the color preference of the customer. Okay, and so this is our visualization. This is that. What do you think this red line denotes? If you said 80, that's a good job. Okay, that's what we expect. But we can see green and silver are slightly different. Okay, slightly different. All right, and then whereas red, gold, and blue are slightly above. All right. And so in terms of our analysis, this is our test statistic. This is degrees of freedom. I'm going to mention this below, but I'm going to mention this now. It's going to be the number of levels, number of categories minus 1. So it's going to be 5 minus 1 gives us 4. And then this is our corresponding p-value. Based on that p-value, you already know what you should do to the null hypothesis. What should you do? You're right. You should reject the null hypothesis. Okay? We should reject it, And we know this. We know that green and silver are really deviating dramatically. I would say green, silver, and red are dramatically deviating from what's expected. Okay? We'll talk about how to get this value in class. But in this video, you know the questions. All right, so why does this research matter? Why does this research matter in real world terms? So you can imagine being a commissioner owning the store. You want to make sure the colors are what, individuals like, or at least choose 3 of the 4 or 3 of the 5, or maybe 2 of the 5 that, individuals actually like, and make sure that you provide those colors, right? So just as you can get them to buy the product, buy the lottery ticket. All right. So you can imagine this is important in terms of customer satisfaction. Okay. In terms of maximizing customer satisfaction, you can make more money. Okay. And also have more revenue. All right. So in terms of the variable, we already said it's the color preference of the customer. And we said it's going to be categorical. Okay. Sorry, not of the customer. The type of color preference. My apologies. The observational unit is the customer who purchased the ticket. Okay. Okay. At a convenience store. Who purchased the ticket? Oh, that kind of insinuates that individual scratch ticket customer at a convenience store. At the convenience store. And then here we're making generalization of all potential scratch-off ticket customers in the Washington state who might purchase. Because though we're looking at that actual one store, we're trying to make generalizations about all ticket customers in Washington State, right? Let's double check that. Yeah, Washington State. Okay. And it's important that I'm making this type of I'm belabeling this because it's important for us to know what we're making generalizations about. Okay. The sample should be those 400 customers, right? The 400 scratch ticket purchases made by customers. Customers from a single convenience store in Seattle. Again, it's a single. Okay. This appears to be it's a convenience sample, right? Because it's only that one location. But it is what it is if you only have access to that information. You should at least note it. That's why I asked this question, so you can at least note that, is a convenient sample. Are we manipulating anyone in this situation? I would argue no. So this is observational study. And this is going to be, again, the chi-square goodness of fit test. And there's a lot of different reasons on why this is the chi-square goodness of fit test. But here are some. So one is that it's a categorical variable, right? One categorical variable. One variable with 5 levels. And we're trying to see if our observed distribution, this is our observed, this 100, 85, 65, 95, 55, matches what significantly differs or matches the actual expected distribution. Our expected distribution would be 80, 80, 80, 80, 80. Okay. All right. So, I know I didn't give you all time, but I'm pretty sure you paused the video. Maybe you paused the video to answer these questions, but go ahead and pause the video and answer this question. All right. So that you paused it, let's go ahead and go through it. So in terms of chi-square goodness of fit, as well as chi-square test of independence, you can only do hypothesis testing, okay? You can only do a hypothesis test. And so the null hypothesis is going to be what? That our expected distribution matches what we observed. One way of saying that is that the proportions, our proportions equals 0.2. And what's wrong with this? It should say the population proportions. We should delineate and say that the population proportion of ticket purchases are equal across all colors. And it's important that we specify what 1, 2, and 3, and 4 are, and 5 are. I'll do that in class, but because of space and time, we just say that P1 through, even if I just said PR, PB, PS for all the different colors, that would signify that. Whereas the alternative hypothesis would be at least one of the population proportions is not equal to what we expect. Okay. And it's not all the proportions. We just need one of them to be off, and therefore it's not correct. At least one color's population proportion differs from 0.2. Okay? And as you can see, I'm providing context here. Make sure when you look for the non-alternative hypotheses, you provide context. Okay? There's only 2 assumptions. Of course, data is random. Data needs to also be random in some way, shape, or form. As you can know, in terms of sampling, it was convenience, a convenience sample, so you should take note of that. And then in terms of our observations, we need to have at least 5 within each category. And so this is actually kind of confusing. So expected frequency for each category is at least 5. What I'm trying to say here is that my observed data has at least 5. So there needs to be at least 5 in each of these categories. Okay. I'll just change the wording so that's not confusing. Observed frequency for each category is at least 5. Okay. And then from there, we already have our test statistic and our p-value from the R output. And so we know what we should do. We should do what? We should reject our null hypothesis. We should reject it. Sorry, this is our test statistic. This is our degrees of freedom. This is our p-value. We know that we're going to reject the null hypothesis because it's less than 0.1. Okay? And then in terms of conclusion, we should tell the commissioner, or maybe you're the commissioner of the Washington State Lottery, well, color does matter. They're not all the same, okay? And so maybe we should highlight the ones that are least different from 80%, right? You can just look at the difference between 80 in each one of these, and wherever the smallest are the ones that you would want to use potentially, or use some other metric. Okay, the data suggests significant variations in colors, with the red tickets being the most popular, but maybe you should keep most of them red, and the silver tickets are the least popular. Maybe you shouldn't have any silver tickets. Okay, and this is valuable. Say, for example, you're trying to maximize customer preferences, as well as your sales and revenue. With that being said, that is the chi-square goodness and fit test. Hopefully that this is helpful in terms of the process. And yeah, thank you.